So section 5.6, indeterminate forms and L'Hopital rule. So we already know they ask you to find the limit for 2x squared minus 2 over x minus 1. X plus 1. By using algebraic form, like the way we learn how to find the limit. So I'm going to say, okay, what I'm going to do here, this one is going to be equal the limit x approaches the negative 1. I'm going to take 2 as a common. The left is x squared minus 1 divided by x plus 1. Then I can factor this one by using difference between two squares. So this one is going to be the limit as x approaches the negative 1, 2x plus 1, x minus 1 divided by x plus 1. Then I'm going to cancel these. So it's going to be the same thing, the limit as x approaches to the negative 1, 2, and x minus 1. Now, the only thing we're going to plug in, so plug in negative 1 is going to be negative 1 minus 1 is going to be negative 2 times 2. That means the limit is going to be negative 4. This is just the regular way to find the limit. So, okay. L'Hopital rules, it says, before you start doing these steps, there's another way to find the limit, but what we're going to do, if you plug in negative 1 here, if I plug in negative 1 here, it's going to be 2 times negative 1 squared minus 2 divided by negative 1 plus 1. So negative 1 squared is going to be 1. 2 times 1 is going to be 2. Minus 2 is going to be 0. That means on the top is going to be 0. Negative 1 plus 1 also is going to be 0. So if I plug in negative 1 here, before I start doing these techniques, if I plug in negative 1 here, on the top and the bottom, and the result is going to be 0 over 0, that means I can use L'Hopital rule, because it's easy way to find the limit. L'Hopital rule, it says, if f and g, two functions, differentiable on the open interval AB with the c, except possibly at c itself. Like you can find the derivative for all points except this point. Assume that the derivative of g is not equal 0 for all x in AB, except the point c also. If the limit, here's the important thing. If the limit of g of x over f of x as x approaches c to produce indeterminate form, one of these forms. That's what we did here. When I plug in the limit and I got the form 0 over 0 or infinity over infinity, negative infinity over infinity, infinity over negative infinity, then the limit from f of x to the g of x is going to be exactly the same thing, the limit for the derivative of f and the derivative of g. So that means instead of finding the limit here, I'm going to find the derivative here, find the derivative for the g of x, then I'm going to check to find the limit for the new quotient here. And again, if the derivative for the new quotient, you're going to get one of these four, you're going to go again and use the L'Hopital again, and keep going until you find the limit for the function. We're going to check that with an example. So the first thing before you're going to check, can I use the L'Hopital rule or no? If you plug in the limit, you're going to get one of these four. 0 over 0, infinity, infinity, negative infinity, 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 negative infinity. That means I can use the L'Hopital rule. I'm going to find the derivative for the top, the derivative for the bottom, and it's going to be easier to find the limit. Let's check that one example. It's going to be easier. So the first thing, you have to check the limit. So if you look at this example, they're telling you use the L'Hopital rule, but sometimes they're going to tell you use the L'Hopital rule because it's up to you. So I need to check, is that indeterminate form? What I'm going to do, I'm gonna plug in 6. If you plug in 6 here, it's going to be 36. It's going to be 36 minus 24 plus 12. And 6 minus 6. That's mean 36 minus 24 plus 12 is going to be 0, 0. So this is indeterminate form. That means I can use L'Habata rule. L'Habata rule says, okay, this is f of x and this is g of x. That means the limit when x approaches to the 6, this is f of x and here is g of x. I'm going to find the derivative for f of x.
So in reality, it's 0 over 0.
If you plug in this one,
Like, what if it's 4 over 0? We'll still use no total.
yeah, so this one equal, here is negative. Now it's going to be 0 over 0. That means this is indeterminate form. That means I can use the Habata rule. Find the derivative for f of x, which is 2x minus 4. Find the derivative for g of x is going to be 1. Now, if you look to the new form, it's easier to find the limit. It's easier to find the limit. If you plug in, it's going to be 12 minus, that means this one is going to be just plug in 6. It's going to be 2 times 6 minus 4. It's going to be 12 minus 4 is going to be 8. So that means this is the limit for this fraction. This is only if you plug in 6 here, you're going to get indeterminate form. That means I can use the Habata rule. Now this one is easy example. Let's check the next one. The next example, find the limit. They ask you use the Habata rule. What we're going to do, the first thing, when you plug in the 0 here, it's going to be square root of 25 minus 0 minus 5 divided by 0, which is equal. 25 minus 0 is going to be 25. That means going to be square root of 25 is going to be 5 over 0, which is going to be 0 over 0. So this is indeterminate form. In this case, I can use the Habata rule. This is f of x, and this is g of x. Going to find the derivative. That means it's going to be the limit when x approaches to the 0. Before I can convert this one to 25 minus x squared to the half minus 5 over x. Then I'm going to find the derivative because here is square root. Find the derivative for f of x. It's going to be the same thing, the limit when x approaches to the 0. I'm going to use the L'Habata rule here. It's going to be half 25 minus x squared to the negative half times the derivative of inside, which is negative 2x. Because the derivative of inside, this is 0, negative 2x, minus the derivative of the 5 is going to be 0, and everything divided by the derivative of g of x, which is x, is going to be 1. Then next step, we're just going to simplify. So it's going to be the limit when x approaches to 0. Cancel the 2 with the 2. The left is negative x. Write down 25 minus x squared on the bottom part. So it's going to be, it's negative x over 25 minus x squared to the half, which is the same thing, the limit when x approaches to the 0, x over negative x over square root of 25 minus x squared. Now, if you plug in the 0, 0 divided by 5, because this is 0, 25 is going to be 5, square root of 25 is going to be 5. So 0 divided by 5, the result is going to be 0. So that's by using the Habata rule to find the limit for this example. evaluate the limit by using the Habata rule. Again, before I start, I'm gonna check. If I plug in the 1 here, going to be 1 to the power 7, 1 to the 7 minus 1, which is equal 0. If you plug in 1 here, it's going to be also 1 to the power 23 minus 1, it's also equal 0, so it's 0 over 0. That means this is indeterminate form, so I'm going to use the Habata rule. Find the derivative here, so it's going to be the limit. When x approaches to the 1, the derivative here is going to be 7x to the power 6. This is 0 over 23x to the 22 minus 0. That means it's the same thing, the limit when x approaches to the 1, 7x to the power 6 over 23x to the 22. Now, if you plug in 1, that's how it's going to be the limit. I cannot plug in 1 here. It's going to be 7 times 1 to the power 6 over 23, 1 to the power 22. And the result is going to be 7 over 23. So here is the limit by using the Habata rule. The same thing for the next example. The limit when x approaches to the 0, sine 2x over sine 5x. Again, we need to check if you plug in 0 here, it's going to be sine 0 over sine 0. Sine 0 is going to be 0. Sine also 0, 0 over 0, this is indeterminate form. That's why I'm going to use the Habata rule. That means this one is going to be equal. The limit when x approaches the 0, sine 2x. The derivative for sine 2x is going to be cosine 2x times 2, which times the derivative of the angle. So cosine 2x times the derivative of the angle is going to be 2. Sine 5x, the derivative for sine 5x is going to be cosine 5x times the derivative of inside, which is 5. Now it's going to be different. If you try to find the limit, plug in 0 here, that's going to be limit when x approaches to the 0. I need to find the limit. I'm not going to plug in, write down the limit anymore. It's going to be cosine 0 times 2 over cosine also 0 times 5. This is 1, and this is 1. So the result is going to be 1 times 2, 1 times 5, and then it's going to be 2 over 5. So here is the limit for sine 2x over sine 5x by using the Habata rule. X squared, because this is the large exponents, and you can go ahead to divide this one by x squared, by x squared, by x squared, by x squared, by x squared. This one going to be infinity, goes to the 0. This goes to the 0. So the left is going to be 4 over 3. This is by a regular way. Now we need to use the Habata rule. So what I'm going to say, okay, if I plug in infinity here, infinity squared is still infinity, times 4 is still infinity, minus 7 times infinity is still infinity, minus 1, so the top part, if you plug in infinity, is going to be infinity. Infinity squared is going to be infinity, times 3 also is going to be infinity, plus 8 is still infinity. That's mean this is indeterminate form, so I can use the Habata rule. That's mean I'm going to find the derivative here. So it's going to be the limit when x approaches to the infinity. The derivative here is going to be 4 times 2 is going to be 8x plus 7 divided by the derivative here is going to be 6x because this one is 0. Now again, I'm going to look. If I plug in infinity, this one is still infinity. infinity divided by infinity. That's mean I can use the Hopital rule again. That's mean I can say, okay, it's the limit when x approaches to the infinity. I'm going to take the derivative again for this one. The derivative is going to be 8. The derivative for 6x is going to be 6. Now, I don't have to plug in the infinity anymore because there's no x. That means this one is going to be 8 over 6. Simplified, it's going to be 4 over 30. That's it. So you can take the Hopital rule more than one time. Check its indeterminate form. Go back again. Plug in infinity. This one is infinity. Plus 7 is still infinity. That means here's infinity. 6 times infinity, also infinity. So it's still indeterminate form. That means I'm going to go ahead and use the Hopital rule. Take the derivative for f of x, it's going to be 8. Take the derivative for g of x is going to be 6. Now determinate the limit for constant is going to be constant. That means 8 over 6. Simplified is going to be 4. Let's take this one also. We're going to solve it by using the Hopital rule, but we need to check, can we use this rule? Because again, it's a limit. They're not going to tell you which method you're going to use. So if I plug in infinity here, it's going to be infinity cubed. That means infinity cubed is still infinity. If I plug in infinity here, the exponential function, when it's infinity over 4, is going to still infinity. That means 5 times infinity is going to be infinity. This is indeterminate form. So I can use the Hopital rule. That means it's going to be the limit. When x approaches to the infinity, I'm going to take the derivative here, which is 3x squared. Here's the important thing. The derivative for the exponential function. Here's the 5. Because it's not going to change anything. Let's do the derivative for e to the x over 4. It's going to be what? I'm going to say d for this one. That's mean the derivative here. There's going to be the same function times the derivative for the exponents. The derivative of the exponents, it's a quotient. So you can say, okay, it's the top times the derivative of the bottom part times the derivative on the top. So 4 times the derivative here is going to be 1 minus 4x, the derivative for the bottom part, which is 0 over 4 squared. So this is 0. That means it's going to be e to the x over 4 times 4 divided by 16 is going to be 1 over 4. So the derivative is going to be 1 over 4 e to the x over 4. That means is going to be the limit when x approaches to the infinity, 3x squared divided by 5 over 4 e to the x over 4. Now let's check. If you plug in infinity, it's going to still the same thing. If you plug in infinity, it's going to still the same thing. Because here, 3 times infinity squared is going to be infinity. 3 times infinity is going to be infinity. Exponential x over 4 also infinity times 5 over 4. So infinity over infinity. That means this is also indeterminate form. So I can go back and use the Hopital rule again. The Hopital rule again, I'm going to take the derivative here. So it's going to be the limit. When x approaches the infinity, it's going to be 6x over. Again, you're going to take the limited the derivative for this one. The derivative for this one, except the 5, is going to be 5 over 16. Or you can do it exactly because Here is the 5 over 4. If you check in the derivative for e to the x, it's going to be the same thing, 1 over 4 e to the x over 4. That means it's going to be times 1 over 4 e to the x over 4. Because the same thing, that means it's going to be the limit when x approaches to the infinity, 6x over 5 over 16 e to the x over 4. Again, we're gonna check again. If I plug in infinity here, it's going to be 6 times infinity, infinity. On the bottom part, also exponential function for infinity is going to be infinity. That's mean infinity over infinity. So I can use the Hopital rule again. This one's going to be equal. The limit when x approaches the infinity, take the derivative here, is going to be 6. Take the derivative here, it's 5 over 16. The derivative for the exponential function is 1 over 4 e to the x over 4. That means it's going to be the limit x approaches the infinity, 6 over 5 over 64 e to the x over 4. Now let's check. Can you plug in the infinity here? That's it. We can't use the Hopital rule again. That means the bottom part, how much is going to be? If you plug in the infinity, it's going to be infinity. That means if I plug in infinity here, this is constant. It's going to be 6 over infinity. 6 divided by infinity is going to be what?
0.
It's going to be 0. Perfect. That means the limit for this one is going to be 0. So if you check by using the Hopital rule, it's easier to find the limit than the regular way. On certain function, on certain limit, it's going to be easier to use the Hopital rule.